Hi, I'm Ellie.
And I'm Taylor.
And today we're going to teach you about the do's and don'ts in driving.
And we're going to teach you the physics behind that as well.
But what does physics have to do with driving?
Well, cars can move according to the third law of motion. The third law of motion states that every action, there's an equal and opposite reaction to every action. The wheels of the car can only move because the road beneath them is pushing back with an equal and opposite force. But let's break it down and teach you more things about being a good driver.
First, speed safety.
One of the most important things about driving is to drive at a safe speed. This means to follow all posted traffic signs and drive at a constant safe speed.
Here's what driving at a safe, constant speed of 10 miles per hour looks like.
Let's take a look at this by using a few types of graphs. First, a velocity time graph.
As you can see, this graph shows velocity versus time. The y-intercept is 10, which represents the car's actual speed. The slope of the graph shows the constant velocity of the car because the slope is 0 and therefore no change in velocity occurred. This graph does not have any sharp dips or increases, meaning a constant velocity took place. We can also represent this motion.
This is a motion map. The dot represents the position the car was at during one interval of time, and the length of the arrow shows the duration of the motion. For this example, the arrows are equal lengths and the dots are equally spaced because the car is traveling at a constant velocity. Now that you're driving, it may seem like you just want to jet off before talking to anyone. But wait, don't do that!
If you don't tell someone where you are going before you leave, and something happens, it can take a while for help to get to you. Also be sure to tell people how long you think it will take for you to get to your position.
Let's show you a hypothetical situation on how to find how long it will take for you to get to where you are going if you don't have a map app on your phone or in your car. Let's say you want to go for a late night ice cream run. You're a safe driver and know that your initial velocity is 0 miles per hour because your car was parked in your driveway. You also know that your favorite ice cream place is 16 meters away and that your acceleration was constant at 2.5 meters per second. How do you find how long it takes for your car to pull into the store? You can use the third kinematic equation to find this. The kinematic equations are a way to predict the motion based on information given. The third one is displacement equals initial velocity times time plus 1/2 acceleration times time squared. Let's substitute the given values into the equation. Now we can simplify the equation to solve for time. We find that the time is 11.3 seconds. Why you wouldn't just walk, I don't know.
Illinois is known for its crazy weather. This can make driving dangerous in poor conditions. In bad weather, safe drivers pay attention to road conditions.
Well, what does this have to do with physics? The coefficient of friction connects it to physics.
The coefficient of friction, represented by the Greek letter mu, is the ratio of the friction force opposing motion to the normal force of an object. Every surface has a different coefficient of friction. For your average road, this value is about 0.7.
When the weather gets bad because of rain or snow, which is quite frequent and unpredictable in Chicago, the coefficient of friction is affected by the water because the road loses friction between the tires and the road itself.
When the road is wet with rain, an average road's mu can drop to 0.4, or when it's icy, 0.2. This can lead to sliding due to the wheels spinning because of a loss of friction.
If you find yourself sliding, be sure to turn into the direction of the slide. That way, traction can be regained on the wheel.
Sometimes when you're in a rush, it seems like the only way you can be on time is to run a stop sign or a red light.
But wait! Don't do that! Not only is that illegal, but it can also be really dangerous. Let's look at a hypothetical crash.
Uh-oh, looks like you ran a stop sign at a stop and were hit by an oncoming car going the opposite direction. Let's say you're driving a Ford Explorer and the other driver is driving a Jeep Cherokee. A Jeep Cherokee weighing at 4,200 kilograms weighs more than your Escape at 3,200 kilograms. You were going 10 meters per second, and the Cherokee was going 12 meters per second. The crash only lasted 3 seconds. When you collide, you stick to one another in a type of collision called an inelastic collision. How do we find the effects of the crash on your car and your person? We can use something called a momentum bar graph to represent momentum before and after the collision. This is a momentum bar graph. But what even is momentum? Momentum is defined as the mass times velocity of an object and is a quantity of its motion. In a collision, the greater mass wins. Having said that, let's go back to the bar diagrams. The left diagram represents the momentum of each car before the collision. Because the Cherokee weighs more, we stack the momentum boxes side by side and 2 by 2. Your Ford Escape only has one box because it weighs less than the other car. Both cars are going the same direction, so we have the diagram showing that by having both cars' bars pointed in the same direction. After the collisions, the cars stick. Therefore, on the right, we stack the boxes above each other. We combine the overall masses to represent the total momentum each car would experience. Look how tall the boxes are. It's just a qualitative way to show how much momentum you would be experiencing. To figure out the exact momentum experience, we can multiply the speed of each car by the mass of each car. For the Cherokee, it would be experiencing 50,400 meters per second, or 50,400 newtons per second. For you, you'd only be experiencing negative 32,000 newtons per second. It's only negative because you are traveling in what we call the negative direction with the coordinate axis. To find out how many newtons you are experiencing in 1 second, multiply the impulse above by the duration of the car crash. For your car, you'd experience about 64,000 newtons. It takes about 4,000 newtons to break a bone, and just over 3,000 newtons to break your spine. This just shows how dangerous not stopping at a stop sign can be for your health and for your life.
We hope you enjoyed our application of physics to driving. Driving is a fun experience that comes with a lot of responsibility.
Be sure to follow our helpful tips if you want to stay safe out on the road.
Bye!